Hello, you are welcome to our lesson of Chemistry Practical. Today we are going to continue with our lesson Chemistry Practical's Redox Titration. And today we are going to perform to show you how to solve this question. For the first lesson, we learned about it, or I taught the student to how the reactions are going to be shown. And our topic for the first topic, redox titration, we learn about the chemical reactions between potassium permanganate and the oxalate from oxalic acid with the acidic medium. It means redox reaction, you have to perform titration with the acidic medium by inducing sulfuric acid. So today I'm going to tell you how to solve these questions, and I will show you practically the ending point of the color changes from one step to another. So you're welcome for the first experiment. If you are not have not ready for the first lesson about the chemical reactions, half reduction reaction, oxidation, half reduction, half reaction, let's communicate with me. I will give you that tutorial video for that lesson. So, redox titration, experiment number 1. We are going to use a solution containing 0.79 gram of potassium permanganate in 0.2 decimeter cube of the solution. That is our data first. The solution number B, 3.15 gram of oxalic acid with hydrated oxalic acid dissolved in 0.5 decimeter cube of distilled water. And our molarity of sulfuric acid, we are going to use 2 molarities. So that's our data. In practicals, you will see procedure one by one. And then you see this question, you are required to find the water crystallization of oxalic acid. I think that is a time enough. Let's we go to the class, to the experiment practically. You will see, you will enjoy, and you will understand the solutions, how to solve these questions. So you're welcome to learn with me. So now we'll proceed with our experiment. After looking at the data, our solution we have solution A, which is potassium permanganate. Now we have already put in the burette. We have solution B, which is oxalic acid, and then we have solution C, which is sulfuric acid, to introduce or to initiate the acidic medium in our solution or in our redox reaction. We have a source of heat in a Bunsen burner. We have conical flask for titration, and we have measuring cylinder for measuring. So be together one step by one to understand these procedures, and they actually have to note the end point for this reaction between potassium permanganate and oxalate from oxalic acid. So this will proceed with our procedure. Actually, we have also thermometer for measuring the temperature of the solution, because oxalic acid with the potassium permanganate react in high temperature, so we have to heat and then to speed up the reaction. The first we measure 25 of oxalic acid, then we pour in a conical flask, then we are going to add the 25 of sulfuric acid, the same measurement, sulfuric acid. Then after mixing, remember we are going to heat. Then the heat, we have to switch on the source of heat, and then we switch on. Then we are going to find the temperature about 70 temperature. I have to put this one, then we are going to wait. When we are waiting, we have to read the initial volume. The initial volume, that is 0. That is 0 volume of permanganate. And then we are going to wait the solution to be at 70 Celsius temperature or Celsius degrees. Before doing this one, I have already taught the theory. If you are not ready for the first or for that theory, you can communicate with me to give that tutorial theory. And after this experiment, we are going to make solution, the solving of this question, to find the water crystallization of oxalic acid. Now in the 60, we wait a minute to reach at 70 centigrade. That is now 0. If it will be more than, you have to wait to cool your solution. And then if it is ready, you switch off, minimize the course of your burner, the gas, and then you are going to heat. The initial volume with that one, and then I will proceed with the titration. Let's be together within a conical flask to see the color change. At the first titration, the reaction is slow, so as the time goes, the reaction will be fast. Make sure your eye is pointing to the conical flask. I'm doing here titration. You see the color is coming and disappearing. Color change is pink. That is the hot solution. That is hot solution of oxalate and the sulfuric acid. Be patient to wait the ending point. Wow, that is our ending point. So from colorless to pink. Why is pink? There is an excess manganese oxide within our solution. So that's why the pink. And this potassium permanganate is self-indicator. That's why we haven't any another indicator outside of this one. I think that is our demonstration, our experiment. Let's go to the procedure to see let's go to the questions to see the solutions. Our volume here is 25. From 0 to 25, that is the neutral or the ending point for this reaction. Thank you for learning through this one. Let's go to the solutions. Okay, after looking at the experiment and then looking at the end color change and then recording our volume, which is 25, let's proceed with the solving. We are going to describe one question. Our solution was solution A. We have this 0.79 potassium permanganate, 0.5, 0.25 deciliter cube. We have solution B of oxalic acid, hydrated, 3.15 gram of in 0.5 deciliter cube of water. We have sulfuric acid, 2 molarity. So this is our data which we are going to use in solving. So we have to note carefully without missing any number. After titration, you have recording the volume. The first thing when you are recording your report, you have to show the real velocity and the vital velocity, and you have to show the table results. We have performed one titration, but you can feel by considering that volume. You can feel the pilot, theta 1, theta 2, theta 3. All of us you can feel that table. Then you have to calculate average volume used of your volume. That is very important for your solving. So myself, I will start apart from table results, apart from average volume used, I will start with balanced chemical equation. I will show you half reaction for oxidation and for reduction, and I will show you the overall reaction. Then we proceed to solve. Our aim of the experiment is we are going to see there is X here. You are required to know, to identify the value of X. So let's proceed on solving. Myself, I will start with the balanced chemical equation. This is redox reaction. In conical flask, we have put sulfuric acid. So that the sulfuric acid is going to initiate the acidic medium with the potassium permanganate. So we have to half reduction. We start with half reaction, half reduction. We take manganese for oxide, react with the acidic. The product is manganese. That's why that is colorless plus water. When we balance, this one is 4, but here we put 4. And here is 8, we put 8. That's come to case of electrons. Here there is 2, but here there is 8 minus 1, there is 7. So in order to balance, we have to add here 5 electrons. I will go first because the first lesson I have shown this equation. That is half for oxidation, for reduction. And half oxidation, there is oxalate. Oxidation. There is oxalate. We're going to give carbon dioxide. When we balance here, this is balanced in element, but ions are not yet. So we have to add this side, 2 electrons. So this is 2, and this is 2. So that is balanced. When you are going to join, create your overall reaction. Overall reaction means you have to join this one, this. Here you consider here, this 5 and this one. So here will be 5, here will be 2, and here will be 5. So this and this will cancel, will be 10, and this and this will cancel, will be 10. So this will cancel with this one. So the overall reaction will be manganese 2, manganese 4, which is 2 here, with 16 hydrogen ion, plus this one 5. The product will be this is cancelled, will be this is 2 plus this one 10, here will be 10, here is 10 plus water 80 water. So this is overall reaction between manganese and the oxalate. Our ratio is 2:5. Is 2:5. So here is 2 and here is 5. The molar ratio is 2:5. That is balance the ionic equation. Another question, to calculate molarity of solution A. We can't start molarity of solution B because B we can't know we have unknown value, so we have to start with the standard solution, and then we are going to find another which is unknown. We can't get the molar mass. So molarity of solution A. Solution A is a potassium permanganate. So according to our data, we have mass and we have a volume. So according to that, we can get a concentration, because the concentration is mass over volume. So concentration is equal to mass over volume. Mass is equal to 0.79 divided by volume 0.25. The answer of this one will be 3.16. This is a concentration. But the molarity is the concentration of the molar mass. The molar mass of this one is equal to 158 per mole. So the formula is molarity concentration of a molar mass is equal to 3.16 divided by the answer will be 0.02. That is molarity of potassium permanganate of solution A. After this one, we have to use this one to calculate the molarity of solution B, which is oxalic acid. We are going to start molarity of B by using molar ratio formula, which is this one. Molarity of acid we have got 0.0. Molarity of potassium permanganate or solution A, that is 0.02. So volume of permanganate from the burette was 25. Number of mole of solution B oxalic acid is 5. And the volume of solution B was also 25 from measuring cylinder or from pipette, and the N A here was 2. So there is 0.02 times 25 times NB, number of mole of oxalic acid, was 5. Here there is 25 times 2. So we can cancel this and this one. This and this is 2.5. So when you multiply here, you get 0.05. That is molarity of oxalic acid. Do you catch me? So after getting molarity of acid, we have to use the concentration in order to get the molar mass of the whole compound. Let's proceed to find the concentration. According to our data, we can get concentration 3.15 over 0.5. That is the mass over volume. We can get concentration, and the concentration of this one will be 3.15 5 divided by 0.5 is equal to 6.3 gram per deciliter cube. So we take this one, we divide by this one, we get the molar mass of the whole compound of oxalic acid. And then we are going to use molar mass as relative atomic mass to calculate the value of water crystallization. So the molar mass of solution B, molar mass is equal to concentration over molality. Our concentration, we have this divided by this one, we get 60.3. And our molality have got 0.05 from the last solution. So we have 60.3 divided by 0.05. The answer will be this one. This is gram per mole. So the molar mass is 126 gram per mole. That is molar mass. So we are going to use this molar mass to remove SI unit will be relative atomic mass. Then we are going to use to solve the whole compound. So molar mass is 100 to 600. Relative atomic mass is 136. And then we are going to use this one to solve this one. So this times 1, 12 carbon times 2 plus 4 times 16 of carbon of hydrogen plus X1 is equal to this one. So I think you see that is how calculated. That is how to solve this question. Thank you for learning through this one. Another lesson will teach you one by one step. Thank you to be with me.